Hey there everyone, Ramesh here. Welcome to Spring MVC tutorial. So this is going to be a full course, and in this course you are going to learn everything about Spring MVC, and you will also learn how to develop Spring MVC based web application using Spring Boot. Well, let's take a look into what you will learn in this course. You will learn what is Spring MVC, and you will learn important Spring MVC concepts, and you will learn how Spring MVC architecture works, and you will learn how to configure, that is how to use Spring Boot to configure Spring MVC, and finally we will build a complete web application, that is student management application using Spring MVC, Spring Boot, and then Spring Data JPA and MySQL database. So this is going to be a project development course, and before developing a project we'll understand Spring MVC concepts and how Spring MVC works within architecture, and how Spring Boot auto configures different beans for Spring MVC. Once we understood everything about Spring MVC, then we'll jump into developing a complete web application, that is student management application using Spring MVC, Spring Boot, Spring Data JPA and MySQL database. Let's first take a look into what is Spring MVC. Well, Spring MVC is one of the popular module in Spring framework. So basically Spring framework has different modules, right? And here you can see Spring MVC is one of the popular module in Spring framework, and Spring MVC module is basically used to build web applications as well as RESTful web services. Okay, just remember Spring MVC is used to develop web applications as well as RESTful web services. And as name suggests, Spring MVC. So Spring MVC module is basically designed based on MVC design pattern, that is model view controller design pattern. Alright, so if you can look at the diagram here, this is the typical flow in Spring MVC web application. We have a controller, view, and there is one more component called model. So Spring MVC basically contains these three components: model, view, controller. And the main advantage of Spring MVC is that it provides a separation of concern. For example, here we have a controller, view and model, right? And these three components are separate. Alright, so main advantage of Spring MVC is that it provides separation of concern. For example, controller component is different, view component is different, and model component is different. Okay, great. And if we use Spring MVC to develop a web application, then controller returns a view. Okay, basically JSP or TimeLeaf or any other views that's supported by Spring MVC. And if we use Spring MVC to develop RESTful web services, then controller should return different format, either JSON or XML or any other format, okay, apart from these views. Just remember, Spring MVC is used to develop both web applications as well as RESTful web services application. In case of web applications, a controller returns views such as JSP, TimeLeaf, etc. And in case of RESTful web services, Spring MVC controller returns JSON or XML or other representational format that Spring MVC supports. Alright, this is a quick overview of Spring MVC. Now let's take a look into the prerequisites for this course. Of course, you should know core Java and then Spring Core and TimeLeaf. So you need to learn first core, Spring Core, because in Spring MVC we basically leverage all Spring Core fundamentals. For example, dependency injection. Okay, so you should learn first dependency injection, that is constructor based dependency injection or setter based dependency injection, and you should also learn Spring Beans and how to configure Spring Beans using Java configuration or annotation based configuration. We are not going to use XML based configuration, so it's up to you. Okay, and apart from that, you should learn Spring IOC and how Spring container works, like application context, etc. All right, so before learning Spring MVC, I highly recommend you guys to learn Spring core fundamentals like dependency injection, Spring IOC, Spring AOP, Spring Beans, and different ways to configure Spring Beans, etc. So next is time leap. Well, we are not going to use JSP as a view layer. In fact, we are going to use TimeLeap as a view layer, because nowadays TimeLeap template engine is one of the most popular template engine used in Spring MVC application as a view layer. So instead of JSP, we will focus on TimeLeap. Okay, so apart from this, uh, you may learn servlets, because Spring MVC is designed based on the dispatcher servlet. And in order to understand how dispatcher servlet works and how to configure servlet in Spring MVC, how to configure filter in Spring MVC, for that you should also learn servlet as well as filter. Okay, alright, so this is pretty much that you want to understand before jumping into Spring MVC. We are going to understand Spring MVC architecture and how the HTTP request is processed. Alright, so before understanding Spring MVC architecture, let's take a look at some of the Spring MVC concepts like dispatcher servlet. As probably you know that dispatcher servlet acts as a front controller, like it provides a single entry point for all the client requests to the Spring MVC web application and forwards request to Spring MVC controllers for processing. Okay, a dispatcher servlet is sometimes called Spring MVC framework servlet. Okay, and dispatcher servlet is actually a servlet. It inherits from HTTP servlet base class, and it has all the servlet lifecycle methods. Typically we configure dispatcher servlet in web.xml, like we configure servlets in web.xml, right? So similarly, dispatcher servlet we configure in a web.xml, that is called a deployment descriptor. So Spring MVC provides different ways to configure dispatcher servlet. Like we can configure dispatcher servlet either in web.xml, or we can use a Java based configuration to register a dispatcher servlet using a Java code. Okay, so just remember, dispatcher servlet is responsible for pre-processing and post-processing the request. Okay, and all the incoming request post come to the dispatcher servlet, and dispatcher servlet will forward that request to the Spring MVC controllers for processing. Handler method. A handler method is a method in Java class that handles incoming HTTP requests. For example, so look at here, this is a employee controller and it has this method like view home page. So this is a normal Java method. When we annotate this method with @request mapping annotation, then this becomes a handler method in a controller. So this handler method is basically responsible for handling the incoming HTTP request. For example, if request comes with slash, then this corresponding method will be executed. Similarly, if request comes with this URL, then this corresponding method will be executed. Similarly, if request comes with this URL, then this method will be executed. So this method is basically called a handler method, which is responsible to handle HTTP request. Okay, understood? And controller class. Controller class is a Java class that contains these handler methods. Okay, for example, so look at here, this is the employee controller. It is annotated with @controller annotation. So when we annotate a class with @controller annotation, then this becomes a Spring MVC controller, and this controller basically has a handler methods which are responsible to handle incoming HTTP requests. Okay, so once we familiar with handler method and controller class and dispatcher servlet, now let us see what are the components involved in Spring MVC architecture. So as we already familiar with the dispatcher servlet, so dispatcher servlet is basically responsible for pre-processing and post-processing the request and responses, and it acts as a front controller. So each and every request first comes to the dispatcher servlet and it will forward that request to the controllers for processing. Okay. And handler mapping. So handler mapping is basically responsible for identifying which controller to process the request. Okay. And handler mapping will send the controller details to the dispatcher servlet. And as we already familiar with controller, so controller is basically responsible to process the request, and it will send a view and model to the dispatcher servlet. And view resolver is basically responsible for resolving a view location. Okay, so basically it will identify where basically the view, that is like GSP or Thymlib template, is located in a project, and it will send a view and the extension back to the dispatcher servlet. Okay, and Thymlib engine basically is responsible to bind a model and view together, and it will produce a HTML response, and it will send back to the dispatcher servlet, and then dispatcher servlet send that response back to the browser for rendering. Okay, so these are the components involved in Spring MVC architecture. Now let's understand Spring MVC architecture and how the HTTP request is being processed in Spring MVC architecture. So look at here the diagram. We are going to understand Spring MVC architecture step by step. So look at here the numbering 1, 2, 3, 4, 5 up to 10. So these are the steps that are involved in Spring MVC architecture, and I am going to explain you Spring MVC architecture step by step. Okay. So as you can see here in the diagram, dispatcher servlet is at the center of our Spring MVC architecture. Okay, all the requests from the web browser first come to the dispatcher servlet. Okay, so this is the first step, and dispatcher servlet asks handler mapping to identify which controller is responsible for processing the request. So this is the second step, and handler mapping will identify the corresponding controller, and it will send a controller details back to the dispatcher servlet. Alright, so this is the third step. Now fourth step is, now dispatcher servlet knows which controller is responsible to process the request. So dispatcher servlet will send a request to that corresponding controller. A controller is responsible to process the incoming request, and it will create a model and view, and then that will be again sent back to the dispatcher servlet. For example, controller can just load a list of employee objects in a model, and it will send a employee list.html Thymlib template along with the model data to the dispatcher servlet. Or we can take an example of JSP. So controller will basically return a JSP with model data to the dispatcher servlet. So this is the fifth step. Now in sixth step, dispatcher servlet gives a view name to the view resolver to get actual view location. Okay, now view resolver is responsible to identify the actual view location, and it will send a view and the extension back to the dispatcher servlet. Alright, so this is the seventh step. Now dispatcher servlet gives a model and view to the view engine. Alright, so this is the eighth step. In ninth step, view engine will basically merge a view template and a model data, and it will produces an HTML, and it sends back to the dispatcher servlet. So this is the ninth step. Finally, in the 10th step, dispatcher servlet sends a generated HTML back to the browser. Alright, so these are the steps involved in Spring MVC HTTP request flow. Now let's take a look into Spring Boot auto configuration for Spring MVC module. So before understanding how Spring Boot auto configuration works for Spring MVC, let's first understand how Spring MVC application looks without Spring Boot. Well, in typical Spring MVC application, we configure a lot many things. For example, we configure dispatcher servlet, view resolver, JSON, and data source beans, transaction manager, and many more things. So let me show you the source code of Spring MVC application in an action so that you will understand more. So look at here, this is Spring MVC Hibernate Crude Web Application. So this is the project I have developed using Spring MVC Hibernate. Okay, I haven't used Spring Boot in this project, and you can find this project on my GitHub profile. So go to Spring MVC tutorial, and in this tutorial repository you can find Spring MVC Hibernate Crude Web Application project. Well, in typical Spring MVC Hibernate project, we need to configure a lot many things. For example, so this is a Java based configuration, and in application context configuration file you can see a lot of beans created manually. For example, session factory. If we use Hibernate in Spring MVC application, then we need to configure these three beans, that is session factory bean, data source bean, and then transaction manager bean. Okay, if we don't use Spring Boot, then we need to configure these three beans if we use Hibernate in Spring MVC. Okay, so this is in all the typical Spring MVC applications. Okay, these three beans should be configured. So apart from that, we are using a JSP or TimeLeap. For that, we are also need to configure view resolver, right? So that I have defined in web MVC config class. So look at here, in this project I have used JSP, so I have configured internal resource view resolver for JSP. So this is a typical bin we need to configure when we use JSP or TimeLeaf as a view layer. So apart from that, we need to configure dispatcher servlet. So there are different approaches to configure dispatcher servlet. Like either we can configure dispatcher servlet in web.xml, that is deployment descriptor, or we can configure dispatcher servlet using Java based configuration. For example, so look at here, abstract annotation config dispatcher servlet initializer. So this is the class that Spring MVC provides, and we can extend this class, then Spring MVC automatically configure dispatcher servlet for us, and then we need to provide a different config class for this dispatcher servlet configuration. Okay, so just understand, like without Spring Boot we need to configure these beans for Spring MVC project. So this is a typical configuration. Okay, you can develop any kind of Spring MVC application, and if you are using Hibernate, then you need to configure all these things. Now we understood that in typical Spring MVC database driven Spring MVC applications requires a lot of configuration such as dispatcher servlet, web resolver, Jackson, data source, transaction manager, among many others. And this is the typical configuration which we need to configure in all kind of Spring MVC database projects. Okay, and if Spring MVC is huge, then we may need to configure few more configuration, and this is a kind of common thing we need to provide in all kind of Spring MVC projects. Now let's take a look into how Spring Boot auto configures for Spring MVC module. Well, Spring Boot automatically configures Spring application based on the dependencies present or not present in a class path. For example, Spring Boot auto configures a dispatcher servlet if Spring MVC jar file is present on a class path. Similarly, Spring Boot auto configures the Jackson bin if Jackson jar is present on a class path. Similarly, Spring Boot auto configures a data source bin if Hibernate jars present on a class path. So in this way, Spring Boot automatically configures all the beans based on the jar file or dependencies present on a class path. Okay, just remember, Spring Boot automatically configure Spring based applications based on the dependencies present or not present in a class path. For example, Spring Boot auto configures dispatcher servlet if Spring MVC jar file is present in a class path. Similarly, for Jackson and Hibernate, Spring Boot provides Spring Boot Starter Web library for developing web applications using Spring MVC. So just remember this dependency Spring Boot Starter Web dependency. So this dependency we use to develop web applications using Spring MVC, or we can also develop a REST-based application, that is RESTful Web Services application using Spring MVC. And Spring Boot auto configuration registers and configures the dispatcher servlet automatically. Therefore, we don't need to register dispatcher servlet manually. Let me show you how Spring Boot auto configures dispatcher servlet in Spring MVC application so that you will understand a little more. So look at here, this is the student management system application. This is I have developed using Spring Boot. Okay, and in pom.xml I have defined different dependencies. For example, we are interested in Spring Boot Starter Web dependency. Well, Spring Boot Starter Web dependency we use to develop web applications using Spring MVC module, and this Spring Boot Starter Web dependency provided by Spring Boot. Okay, and Spring Boot internally uses Spring MVC dependencies or libraries. Okay, so Spring Boot is just a wrapper on top of Spring framework, and Spring Boot internally uses all Spring framework libraries. Similarly, we are focus on this Spring Boot Starter Web dependency. So this dependency provided by Spring Boot, and this dependency internally uses Spring MVC libraries. For example, let me go inside this dependency, and there we go. So if you can look at its internals, here you can see it internally uses Spring framework, that is Spring Web dependency, and this dependency is provided by Spring MVC module. Similarly, Spring Web MVC, this dependency also provided by Spring MVC module. Okay, so just remember, Spring Boot provides Spring Boot Starter Web dependency, and this dependency internally uses Spring MVC libraries. Okay, and whenever Spring Boot finds this dependency in a class path, then Spring Boot will automatically configure dispatcher servlet. Okay, Spring Boot will automatically configure dispatcher servlet, and if Spring Boot finds Spring Boot Starter Data JPA dependency in a class path, then Spring Boot will automatically configure all the beans, for example data source bean, transaction manager bean, etc. Because Spring Boot Starter Data JPA dependency internally uses Hibernate as a JPA provider, so hence Spring Boot will automatically configure all the beans that are required to connect with the database. Okay, just remember these dependencies. These are the frequently used dependencies in Spring Boot application. And here is one more dependency, that is Spring Boot Starter Timeleap dependency. If Spring Boot finds this dependency in a class path, then Spring Boot will automatically configure a view resolver for Timeleap template engine. Okay, great. Now we pretty much understood how Spring Boot auto configures for Spring MVC module. Now let me show you one more important class here, that is dispatcher servlet auto configuration class. So Spring Boot team has basically written auto configuration classes for different beans. Similarly, dispatcher servlet auto configuration class. So this class basically Spring Boot will execute when it finds Spring Boot web starter dependency in a class path, and all the auto configuration dispatcher servlet auto configuration logic has written inside this class. For example, look at here, dispatcher servlet instance is created. Okay, and here dispatcher servlet instance is registered. So this is just for dispatcher servlet auto configuration. There are different auto configuration classes provided by Spring Boot to configure different configurations automatically. Now we pretty much understood how Spring Boot auto configuration works for Spring MVC. So whenever Spring Boot finds dependencies on class path, based on the dependencies on class path, Spring Boot will auto configure all the required configuration for Spring MVC applications. Alright, great. We are going to build a simple student management system web application using Spring Boot, Spring MVC, TimeLeap, Spring Data JPA, and MySQL database. Alright, and here are the tools and technologies that we'll be using in this course. We're going to use Java 16, which is the latest release of Java as of now. And make sure that you have installed Java 16 on your machine. You can use Java 8, 11, or 15 as per Java installation on your machine, but make sure that you use Java 8 plus. And we're going to use latest release of Spring Boot and Spring MVC and Spring Data JPA. Spring Data JPA internally uses Hibernate as a JPA provider, and we're going to use a MySQL database to store and retrieve the data, and we're going to use TimeLeap template engine to develop the view layer, and we use Eclipse STS ID. Alright, now let's take a look into Spring Boot MVC project architecture. So this is the standard architecture that we are going to follow to develop our Spring Boot application. And this is the 3-tier or a 3-layer architecture. It has a controller layer, service layer, a repository or a DAO layer. Okay, this is a widely used architecture in project development. So basically controller layer holds all the Spring MVC controllers, and service layer basically holds all the service classes. It has a business logic, and the repository or a DAO layer holds all the persistence or a database related logic, and the repository or DAO layer is responsible to talk with MySQL database. So this is the 3-layer architecture. Now let's come to Spring MVC architecture. So look at here, this is the MVC architecture, or you can say MVC design pattern. We have a controller, view, and there is one more component called model. So controller is basically responsible to process the request, and it will return model and view to the browser to render the page. Okay, so this is the MVC design pattern. We are going to use Spring MVC. Okay, so controller layer basically process the request, and it will get the data from the database by using service and repository layer, and that model data basically bind to view, and that generates a web page. That web page will be displayed on a browser. So this is the simple Spring MVC flow that we are going to implement in this project. Now, before implementing this project in this course, let's take a look into what we are going to build in this course. We are going to build a simple student management system application, and this is really a simple application, guys, but you can make this project a little bit bigger by adding other modules like student management module, subject management module, login and registration module, etc. In this course, I am going to implement only one module, that is student management module, and we create a base, and based on student management module, you can create other modules. Okay, I am going to create a base for you so that you can use this base, and you can extend this project. Well, let's take a look into what are the features that we are going to implement in this course. We are going to implement list students feature, and here we list all the students and then add students. So let's go ahead and let's add a student here. First name Ramesh, last name Padtare, and email ID ramesh@gmail.com, and click on submit, and there we go. Student is successfully added to the list students page. Let me add one more student here. Let's say Sam, and last name is Jadhav, sam@gmail.com, and hit submit button, and there we go. Now let's update one of the student. Let's say Ramesh, and let me update the first name and email ID and also the last name, and hit submit button, and there we go. Student successfully updated, and we have a delete button here. We can delete the student. Okay, so this is a pretty simple student management system application that we are going to build in this course, but you can add modules this project. So basically we are going to create a base. All right, great. So without further ado, let's head over to STS ID and let's start coding. So this is completely a project development course. In this course we will learn line by line coding, building student management system. All right, great. Let's jump into Spring Toolsuite IDE and let's start building student management system. Well, in order to create a Spring Boot project, go to the file, new, and then choose Spring Starter project. And look at here, this is a Spring Initializer website which is integrated in Spring Toolsuite IDE. So instead of going into Spring Initializer website and creating a project over there and importing manually in Spring Toolsuite IDE, Spring team has integrated Spring Initializer in Spring Toolsuite itself, so that we can go ahead and we can create Spring Boot project using Spring Initializer in Spring Toolsuite IDE itself. Okay, so let's go and let's give project name as Student Management System and choose project type as Maven here, and packaging as a Java version 16. So Java version 16 is the latest as of now. You can use Java 11 or 8 as per your Java installation on your machine, and language Java. And I give group ID as net.java guides, but you can give any group ID that you want. And artifact ID is same as name of the project, and description is something like student management system using Spring Boot, and timelib packaging as a net.javaguides.sms. SMS means student management system. And once you are happy with the details, click on next. And here we have Spring Boot version. So this is a stable and latest release of Spring Boot which is recommended by Spring team. So let's keep this default Spring Boot version as it is. And now we're going to choose the dependencies. So let's go ahead and let's choose Spring Web dependency. So we're going to create a Spring MVC application. So let's choose Spring Web dependency. If you just mouse over on this dependency, you can able to read the description of this dependency. So Spring Web dependency we use to build web application as well as Spring RESTful web services using Spring MVC. And this dependency internally provides Apache Tomcat as a default embedded container. We're gonna use Spring Data JPA to talk with the database. So let's pick up Spring Data JPA dependency. Spring Data JPA is just an abstraction layer on top of JPA, and it provides, it internally uses Hibernate as a JPA provider. And we can use Spring Data JPA to reduce a lot of boilerplate code that is required to develop a DAO layer. So I highly suggest you guys to use Spring Data JPA. And next we are going to use Timelib as a view layer. So let's go and let's pick up Timelib template engine dependency, and we are going to use MySQL database to retrieve and store the data. So let's choose MySQL JDBC driver, and we are going to also use Spring Boot DevTools dependency. So this dependency is very useful. So whenever we do some changes in our Spring Boot application, we don't have to manually restart our Spring Boot application. So this dependency will take care of live reloading and configurations for enhanced development experience, etc. So once you pick up all the required dependencies, then click on finish. Alright, so Maven will take a couple of minutes to download all the dependencies from the internet, and we're gonna add JDK 16 to our Spring Boot project. So for that, right click on the project, go to the properties and go to the build path, and in a library, so look at here, by default Java standard edition 13 is added, but we are going to use JDK 16. You can use Java 11, 8 or 13 as per the Java installation on your machine, but I am going to use Java 16 which is the latest release of Java. So click on GRE system library, edit and alter GRE. So I choose JDK 16, apply and close. Okay, great. Now once we create Spring Boot project, next step is we're gonna create a standard packaging structure for our Spring Boot project. So right click on base package, new, and then choose package, and let's go ahead and let's create a controller package here. So within a controller package we keep all our Spring MVC controllers. So let's go and let's create one more package and let's name it as service. So we keep all our service packages under service classes under service package. Next, create one more package and let's name it as a repository. So we keep all our Spring Data JPA repository under a repository package. Next, create one more package and let's name it as entity. So we keep all JPA entities inside a JPA entity package. Okay, great. So we'll create a few more packages as required, in a project development in further steps. So let's keep these packages as of now. Alright, once we create a packaging structure, next step is we need to configure MySQL database details in our Spring Boot project. So we typically configure all database related details in application.properties file. So before configuring MySQL database details in our project, first we need to create a database in MySQL server. So let's head over to MySQL Workbench. So make sure that you have installed MySQL Server and MySQL Workbench on your machine. So MySQL Workbench is basically a client which we use to interact with the MySQL Server. So in order to create a database, just type create a database and followed by name of the database. Let's say SMS, that is Student Management System, and just execute this SQL statement and refresh the schemas, and there we go. SMS database is successfully created. Now let's go back to our STS ID and go to application.properties file, and here we configure MySQL details. For example, just configure JDBC URL now, spring.datasource.url, and just provide a property something like JDBC :MySQL. So this is a standard JDBC URL format, followed by localhost. So here I am giving localhost because our MySQL server is located on local machine. Okay, if your MySQL server is located on other machine, then you have to provide IP address of that machine here, or local or host of that machine here. Okay, and followed by the port of this MySQL database, followed by name of the database, that is SMS, and then we add a few more attributes like use SSL equal to false. We are going to disable SSL, and let's add a few more properties to this URL, that is server time zone. So server time zone UTC, and we disable lazy date time code. Okay, pretty simple. Similarly, let's go ahead and let's configure database username and password. Spring.datasource.username. So in my case the username is root, and let's similarly configure password .password root. So in my case my database username is root and password is also root, but make sure that you will replace username and password as per your MySQL server installation on your machine. Okay, don't forget to replace username and password as per your MySQL setup. Now we're going to configure Hibernate properties here. So Hibernate basically requires a dilate to generate SQL queries for a chosen database. In our case we have chosen MySQL database, so we're going to add Hibernate dilate for MySQL database. So let me quickly add here spring.jpa.properties.hibernate.dilate, and followed by the name of the dilate, that is MySQL 5 InnoDB dilate. Alright, great. So make sure that whenever you use a database with Hibernate, and make sure that you will add Hibernate dilate for that particular database. In our case we are using MySQL database, so hence I have added MySQL Hibernate dilate over here. Similarly, let's add one more Hibernate property, that is AutoDDL. So we are going to generate our database tables automatically by using Hibernate feature. So let's configure that property here, spring.jpa.hibernate.ddl auto. I am going to provide a value as update. So here I have provided a value as update because we are going to create a tables in a database if they are not exist, and we are going to update the existing tables. So there are few more values for this property like create -drop or create or validate, but this update value makes sense for me That's why I have given update here. And we are going to also set a logging level to see the Hibernate generated queries. For that, just type the property logging.level and then org.hibernate.sql equal to, let's give debug. It's pretty simple, isn't it? So once we configure all the details in application.properties file, let's go ahead and let's create a JPA entity for student management application. So the JPA entity in our case is student. So right click on entity package, new, and then choose class, and let's give JPA entity name as student, and let's define the properties inside this class, that is private long id and then private string first name, private string last name, and one more is private string email. So to keep it simple, I added only these 4 fields, but make sure that you will add the fields in a student class as per your requirement. Now let's go and let's generate getter setter methods to access these private fields. Right click, source, and generate getter setters, select all and hit generate button here. Now we are going to create a parameterized constructor. Right click, source, and generate constructor using fields, deselect id here and click on generate. So whenever you create a parameterized constructor, then make sure that you will also create a default constructor, because Hibernate internally uses proxies to create objects dynamically and it needs a default constructor. So whenever you create a parameter constructor, make sure that you will also create a default constructor in JPA entity. Okay, so now look at here, student is a simple Java class. So let's make this simple Java class as a JPA entity by using JPA annotations, that is at entity JPA annotation, and then we are going to map this entity to database table. So for that we are going to use add table annotation here just to provide a table related details. So let's provide a table name here. So table name in our case students. Now we need to add a primary key for this table. So for that we're going to use add id annotation from javax.persistence package, and we're going to also use primary key generation strategy here. So in order to provide a primary key generation strategy, we're going to use add generated value annotation here, and it has a strategy attribute, and we can specify primary key generation strategy here. Okay, so we are going to use identity as a primary key generation strategy. Alright, perfect. Now what we're going to do is we're going to map a column name for these fields. In order to do that, we're going to use add column annotation. So add column annotation has attribute called name, and we can use a name to specify column name here, post underscore name, and you can define this column as a not null by using null label attribute. Null label equals to false. Similarly, let's add a column annotation for last name as well. Name equals to last underscore name. Similarly, let's add for email. Name equals to email. Okay, great. So just remember, if you don't add table annotation to JPA entity class, then JPA is smart enough to provide a table name as name of the class, and if you don't add column annotation to map a column name, then JPA is smart enough to provide a column name as a field name. Okay, for example, if you don't add column annotation to first name field, then JPA will give a column name as the name of the field, like this. All right, perfect. Now what we're going to do is we're going to create a JPA repository. So go ahead and right click on repository package and then choose interface and just give interface name as student repository. Hit enter and let's extend this interface from JPA repository. So look at here, JPA repository has two parameters. First parameter is the type of the JPA entity. So in our case we have a student JPA entity, and second parameter is type of the primary key. Okay, just remember JPA repository has two parameters. First is the type of the JPA entity and second is the type of the primary key. Alright, so if you go inside a student class, you can see here the type of the primary key, that is ID, is long, and that long data type we have specified here as a second argument. Okay, great. Now we don't have to add repository annotation on top of student repository interface, because this JPA repository interface has a default implementation class, that is simple JPA repository. Okay, simple JPA repository is the implementation class of JPA repository, and if you go inside a simple JPA repository, this class already annotated with add repository annotation. Hence we don't have to add again add repository annotation on top of student repository interface. So just remember these points. Sometime beginner might confuse and add repository annotation here. Actually we don't have to add repository annotation to student repository or any other repository that you create, because JPA repository already take care of it. Like a simple JPA repository is the default implementation class of JPA repository interface, right? And it has already annotated with add repository annotation. And again, one more important point is JPA repository interface by default provides a transaction for all its methods. For example, simple JPA repository is a default implementation class of JPA interface, right? JPA repository interface, and it has annotated with add transactional annotation. And if you can see its method, all the methods are by default transaction, because look at here, add transactional annotations are added to all its public methods. It means that JPA repository by default provides transactional to all its methods. Hence we don't have to again add transactional annotation in a service layer. Okay, great. Now let's go ahead and let's create a service layer. So just go to service package, right click on it, new, and then choose a interface, and let's give interface name as student service. Okay, and we're gonna create one more package within a service package, and let's name it as IMPL. So typically we use a dependency injection, that is Spring provided dependency injection, and in order to loose couple all the dependencies, we're going to use interface, and we create a class to implement an interface. So for that basically we use a naming conventions in a package, like IMPL is for implementation classes. That's why I have created IMPL package here. So go ahead and create a class, right click on IMPL package, new, and then choose a class here and just give class name as student service IMPL. So this is the naming convention typically we use to name to the class, and this class implements student service interface. Okay, great. Alright, so one more step is we need to create a student controller. Right click on controller package, new, and then choose class, and let's give class name as student controller and hit enter, and let's annotate this class with add controller annotation. Okay, great. So we add control annotation to this class because we need to make this class as a Spring MVC class to handle the requests, right? Now if you see here, our base is ready. Okay, our base is ready. Now we are going to create features for our student management system. So first we're going to implement end-to-end list students feature, and then we'll see how to implement add student feature, and then update student feature, and delete student feature, and etc. So first we'll focus on implementing list students feature. Okay, so in order to implement this feature, first we're going to change a backend part, and then we'll move to front end part. So in order to make changes at a backend part, we'll go with the student repository. So student repository already gets all the CRUD methods to interact with the database, so we don't have to change anything in student repository. And then next is we move to student service and student service IMPL. So inside a student service, we're gonna define a method here that is get all students. List of student. So make sure that you choose a list from java.util package, and the type is student, and the method name is get all students. Okay, great. Save the file, and let's go to student IMPL class, that is student service IMPL class, and just mouse over on it. Okay, and we need to implement the method that just we have defined in student service, right? So go ahead and click on add implement method. So before implementing this method, let's first annotate this class with add service annotation. So make sure that whenever you create a service class, then make sure that you will add service annotation on top of it. Alright, and we are going to also inject the dependency here. So we are going to use constructor based dependency injection to inject the dependencies. So we are going to use student repository here. Student repository. Okay, so as we are using constructor based dependency injection, so let's go ahead and let's create a constructor here. Right click, source, and generate constructor using fields. So we have only one field, that is student repository. And just remember, whenever the Spring Bean has only one constructor, then we can avoid using add annotation. Okay, we don't have to use add annotation here, because this Spring Bean has only one constructor. Okay, great. Now let's go and let's implement get all students method now. So get rid of this comment, and here we're gonna call student repository. So student repository basically provides all the CRUD methods. Okay, and we're gonna call find all method. So find all method basically returns a list of students. Perfect. Now we have done a changes at a service layer. Now it's time to change a controller layer. Okay, let's move to student controller, and within a student controller we are going to inject first the dependency, that is student service. And as we are using constructor based dependency injection, so let's go and let's create a constructor for this class. And if Spring Bean has only one constructor, then we can omit at annotation. Now we are going to create a handler method. handler method to handle list students request and return model and view. Okay, so just create a method here, public. It returns a string, that is a view name as a string, and then just give a method name is as list student, something like this. And then let's annotate this method with @getMapping annotation, and let's provide a URL here. The URL is students. Okay, and let's add a model as a method argument to this method model. So make sure that you choose model from org.springframework.ui package. Perfect. Now let's add a data to the model dot, just call its method, that is add attribute with key value pair here. So the key is students and value is we retrieve a list of students from a database, just call student service, and student service has a method that is get all students method, right? Yeah. And next we just return a view from this method, return a view, the view name is students. Okay, so we haven't created a students view yet, we are going to create right away. Alright, so go ahead and just expand the resources folder, and under resources folder you can see here templates folder. So basically Spring Boot will auto configure a view resolver for ThemeLib. We don't have to manually create a view resolver bin for ThemeLib, because Spring Boot will automatically configure a view resolver for ThemeLib whenever it will find a ThemeLib dependency in a class path. Okay, we have added a ThemeLib starter dependency in a pom.xml. So Spring Boot will automatically configure all the view resolver and other dependencies for ThemeLib. We don't have to manually configure. And one more important thing is Spring Boot will by default find all the ThemeLib templates under templates folder. Hence we need to keep all the ThemeLib templates under templates folder. Okay, understood? Just note it down, these points. Now let me copy the students view and just right click on templates folder, new, and then go to others and just search for HTML file. Okay, and just give HTML file name as students.html. Okay, let me just expand this templates folder and look at here the flow. Student controller has a list students handler method, it returns a view, and this view we have just created here. And now model has a list of students. Now we are going to display this list of students in a view, that is students.html. Okay, I hope you understood the flow. Now we are going to design a HTML table to display a list of students in students.html file. Let's get rid of this default title and just provide title as student management system. And one more important thing is that we are going to use Bootstrap CSS framework to style our web pages. CSS library is very popular for developing responsive layouts. So we are going to use Bootstrap 4 to style our web pages. So go to the Chrome browser and just type Bootstrap CSS CDN. Okay, Bootstrap for CSS CDN. So we're going to use CDN links instead of downloading and adding Bootstrap files to project. Scroll down and here just copy this CDN link and let's go back to our project, and just below title paste this dependency and just format the page. Yeah, there we go. And let's go back to browser again. If you are new to Bootstrap, then I highly recommend you to read about a Bootstrap. Okay, go to the components here and just go through these important components in Bootstrap, and also the content and a layout. Okay, so go ahead and click on tables here, and look at here, we are going to use Bootstrap table CSS classes to style our table. Alright, great. So we are going to use Bootstrap table CSS classes. So let's keep open this page as it is, because we are going to use a lot of Bootstrap CSS classes. Now let's go ahead and let's create a div here, div, and let's add a Bootstrap CSS class to this div, that is a container. So we are going to wrap up all the HTML code inside this container, and after that we are going to create a div again with a Bootstrap CSS class, a row, and then here we are going to create a heading, that is a h1. This is a page heading, that is list students. After that we're gonna create a table now. So after the div with a class, Bootstrap class row, we're gonna create a table here, and let's add a Bootstrap CSS classes to this table, and go to the browser again, and look at here the Bootstrap CSS class table. And if you want to make the table like this, then you can use a Bootstrap CSS class table dark. And if you want to make table like this, then you can use Bootstrap CSS class, that is table header dark. Okay, and so let me copy this Bootstrap CSS, that is table stripped, and let me paste here, and let me copy one more Bootstrap CSS class, that is table bordered, and let me paste here. Okay, so within a table we're going to create a table header, and let's add a Bootstrap CSS class to this table header, that is table hyphen dark. And then we're going to create a row here, and then we're going to define a table column, so first is student first name, and let's define few more columns, that is student last name, and then student email. And here we define column for actions like update, delete, and etc. Okay, so this is the table header. After that we're going to define table body, and then table row here. Perfect. Now we need to display this table row dynamically, because if you see here student controller, we have added a list of students to the model, and we are going to display this list of students in a students file, right, students view. And this list of students we are going to iterate and we are going to display in a table body. So for that we are going to use th colon each attribute. So just remember, this is a TimeLeap attribute which we can use to iterate over a list of students, and then just access the students variable by using TimeLeap notation or syntax, that is dollar within a curly braces students. So this for each, that is th colon each attribute, just work as a for each loop, and here we need to get a student from students. Okay, and if you can just mouse over on this attribute, it says undefined attribute name, because we need to refer this attribute from official website of TimeLeap. So in order to in order to remove these warnings, what we can do is we can add a reference link to TimeLeap official website. So go to HTML here and just add XMLNS followed by colon th and then followed by the official website link of TimeLeap. And if you can just mouse over here, the warning is disappeared. Okay, so these tags or these attributes are typically referred from TimeLeap official website. Now this is the th colon each attribute to iterate over a list of students. Now we're gonna display student name, first name, last name and email. So look at here, this students comes from student controller here. Okay, we are going to access this key by using TimeLeap syntax like this. Now let's go and let's use td here and then th colon text in order to display a text. So this is the TimeLeap notation or syntax to display a model data, that is student is in our case is a model student, and model attribute, that is first name. Okay, similarly let's display last name and email as well. Student dot last name, student dot email. Perfect. Now let's run our Spring Boot application and let's see how it works. So go to our student management system application class. So this is the main entry point class of our Spring project. So right click on it and run as Spring Boot app. So look at here the statements on a console. Create table students. So students table is successfully created by Hibernate automatically. We don't have to manually create the table. And our Spring Boot application is up and running on embedded Tomcat server on port 8080. Now let's head over to the browser and let's access this application. And the URL for our list students is /students. Okay, we're going to use this URL to access this method handler. Alright, in a browser just type localhost 8080/students and hit enter, and there we go, list students, and this is the table, student first name, last name, email and action, and there is no records exist in a students table. Now we are going to add records to the students table. Okay, great. So instead of adding records manually in a database, what we're going to do is we're going to write a code to add records to the table. Alright, so go to the Spring Boot main entry point class and we are going to implement here command runner command line runner interface, and this provides a method called run. So this run method basically executes when we run our Spring Boot application. So here I want to write a logic to insert few student records. Before that, we are going to inject student repository object. Okay, student repository and then student repository, because we are going to call student repository methods, right? That's why we are going to inject here. Perfect. Now let's go and let's create student object, student, and this is student 1. Let's use a constructor here, and post name let's say Ramesh, and last name let's say Fadtare, and email something like ramesh@gmail.com, and just call student repository and then save, and just pass student 1 object to this save method. So let's go ahead and let's insert a few more student objects. Student 2 equal to new student, okay, and let's add a second student, something like Sanjay, first name, second name adds Jadhav, and email ID something like sanjay@gmail.com, and just call student repository and then call its method, that is save method, and then pass student 2. Okay, similarly let's copy this and paste it here, and let's name it as student 3 and give student 3 as Tony, post name as Tony, and second name as Stark, email as tony@gmail.com, and just pass student 3 to the save method. Okay, to keep it simple, let's keep these 3 students as it is, and you don't have to restart the Spring Boot application because we have added Spring Boot DevTool dependency, right? So whenever we make some changes in Spring Boot application, then this dependency will restart the server. Now let's head over to the browser again and let's refresh here. Okay, and here we go. So look at here, all the students are successfully stored in a database, and these students we can able to see in a web page. It means that we have successfully implemented list students feature. Now next is we are going to implement add student feature end to end. Okay, great. So basically we are going to add a button over here just right below list students page heading, and once we click on add student button, it should navigate to create new student page. Alright, let's go ahead and let's add a button first. Alright, so let me comment out this code because we have already added 3 records to the MySQL database, and go to students.html file. So let me stop the server. Okay, and just right below this heading we are going to add a button, right? So here what I'm going to do is I'm going to create one more div here, and let me add a bootstrap CSS class, that is row, and then I'm going to add one more div here, and let's say column. I'm going to just use a bootstrap CSS grid system to provide a size for the page, and here I'm going to create a anchor tag, and I'm going to use th:/href thymlib attribute to provide a link for this button. So remember, this is the syntax to provide a link for anchor tag using thymlib attribute. So at followed by curly braces. Within curly braces we provide the URL, that is students new. Okay, so this is the request URL that we are going to handle in student controller bit later. And then let's add a bootstrap CSS class here, that is button, and then button primary, and then button small, okay, and margin bottom 3, and let's give button name as add student. Okay, and we are going to handle this request in student controller. For that we are going to write a handler method here. Just go ahead and create a method public student, and this is create student form is a method name, and let's annotate this method with @getMapping annotation, and just provide the URL, that is /students/new, and we're going to pass a model object as a method argument. Okay, and here we're going to create an object of student class here, student equals to new student. We are going to create a empty student object here, and this is a very important step. We create here empty student object to hold a student form data. Okay, create student object to hold student form data. Okay, perfect. Now we're going to add this data to the model dot add attribute, and the key is student. So the key is student and value is the empty student object. Okay, and just return the view, that is create underscore student. So this view we haven't created it, that we are going to create it right away, create underscore student. Okay, so go ahead and create this view now. So go to the templates folder, right click on templates folder, new, and then choose other and search for HTML file, and just provide this file name as create_underscore student.html, hit enter. Okay, now go to the students.html file, and let's copy this bootstrap CSS link and also the title. Okay, and just replace title with this copied content, and go to students.html again and just copy this link and just paste it here, and go to the body and just add a div here, and the bootstrap CSS class, that is container, and then create a one more div. Okay, and let's add a bootstrap CSS class, that is a row. Okay, and then create a one more div, and the bootstrap CSS class. So look at here, we have added a couple of bootstrap CSS classes. So we have added these 3 classes to support the different devices: large device, mid-size device, and small device. And this is the bootstrap CSS class to align the form at the center, and we're going to add a border to the form. That's why I have used card bootstrap CSS class here. Okay, now we are going to add a heading to this page. For that I'm going to use h1 tag here, something like create new student, and we are going to align this heading at a center. For that we are going to use bootstrap CSS class, that is text center, and after that we're going to use a div here once again, and let's add a bootstrap CSS class, that is card body, and within this div we are going to create a form. Okay, form, And look at here, we are going to use TimeLeap attribute, that is th::action, to define the action for this column. Okay, so action is the request URL we define here, at, and then students. So remember here, at represents the context path of your application, and context path is nothing but your application name. Okay, so TimeLeap needs this symbol to refer to your context path of your application. And then within a curly braces we just specify the request URL, and after that th::object, and here we access the empty student object that we have added in a controller. In order to access that object, we are going to use TimeLeap syntax $ within a curly braces student. Okay, so this student object we have provided in a student controller here. Okay, we have added to the model, and in order to access this empty student object, we have used th::object, and then $ within curly braces we have provided the object name. Alright, and we are going to add a method, that is post. Alright, it's pretty much. Now what we're going to do is we're going to design the form now. So let's add a div here, mine bootstrap CSS class, that is form group. Okay, and then add a label here. Label is student first name, and then input field, input text field. Okay, type is text, and then name equals to first name, and th:: field equals to first name, and then placeholder, enter student first name. So remember, this is very important, th:: field. So this is again a TimeLeap attribute that we are going to bind this input text to the post name, and this post name should equals to the post name field that we define in a student class. Okay, this field first name should match to this post name string. Okay, so basically TimeLeap will bind a value to this model attribute, that is first name. And here we are going to provide a bootstrap CSS class for this HTML element, that is form control. Alright, great. Now let me simply copy this and paste it here, and let's change the student post name to student last name, and here also from post name to last name, and here also from post name to last name, and here also enter student last name. Okay, pretty simple. Let me just copy this, and let's similarly add for email. This is student email, and name should be email, and field should be email, and enter student email. Okay, now right after this div we are going to add a submit button for that div class, and here we are going to add a bootstrap CSS class, that is footer body, and within that we are going to add a button. Okay, button of type submit, and let's add a bootstrap CSS classes button and button primary, and let's give button name as submit. Okay, so this bootstrap CSS class is not exist. I think the box footer is the bootstrap CSS class name. Okay, just make this small change. Okay, so once we enter all the details in a form and then submit, then we need to handle this request, right? In order to handle this request, we need to create a handler method. So let's go to student controller, and here we are going to write a handler method to handle this form request. So go to student controller, and here create a method public string, and let's call it as save student. Okay, and let's annotate this method with @post mapping annotation, and let's define the URL, that is /students. Okay, and we are going to use @model attribute annotation to directly bind a form data to the object. The object is student, and we are going to bind to student entity. Okay, now what we're going to do is we're going to save this student object to the database. For that, we're going to call student service, and let's call its method save student. So we haven't created save student method yet, so go to student service interface, and here we are going to create save student method save student, and we are going to pass student object as a method argument, and let's implement this method in student service IMPL class. Okay, get rid of this comment, and here we're going to call student repository and then save student. That's it. And let's go back to our student controller again, and here we are going to call student repository, not student repository, student service, and then call its method, that is save student, and just pass student object to it. Perfect. And now here we are going to return, basically we are going to redirect to students page. So once user successfully add a student, then we need to redirect to students page, right? So for that, we are going to write here the statement like redirect to students page, and students page means here for this request. Okay, so after executing this method, it will redirect to this method handler. Alright guys, let me quickly run our Spring Boot application and let's see how it works. Perfect, our Spring Boot application is up and running. Let's head over to Chrome browser and let's refresh, and there we go. Add student button looks good, so just click on add student, and I think there is a small issue. Let me see what is the issue. Post name is not valid. Okay, yeah, so look at here, the exception clearly mentioned, like we have used dollar and curly braces. Basically, in order to bind the input text, we have to use star curly braces. Okay, all right, let's head over to STSID and let's fix this issue. So go back to create student.html. So typically we have to use here star and within a curly braces first name. So this is the syntax to bind data to the model attribute first name. And similarly, let's do it for last name, star and within a curly braces last name, and similarly email, star within a curly braces email. And let's save the file and let's go back to the browser and let's refresh this link, and there we go. Create new student form displays, and now we are going to add a student. For example, let's say John, last name something like Sina, and then student@gmail.com, and click on submit, and there we go. A student is successfully added to the list. Let me go ahead and let me add one more student. Let's say Ram Jadhav, ram@gmail.com, and click on submit, and there we go. A record is successfully added to the list. It means that we have successfully implemented add student feature. Alright, so far we have implemented list students feature and add students feature. Now what I'm going to do is I'm going to add a header to our student management application. In order to add a header, just go to Google, okay, and we're going to use a Bootstrap for navbar, okay, and hit enter and go to W3 schools. Alright, and just scroll down and scroll down and look at here. This is the collapsing the navigation bar, and it supports multiple devices. Okay, so let's go ahead and let's copy this code snippet, and this is a code snippet that we are going to use, and this is how the header looks like. Okay, so go ahead and open students.html file, and within a body, just body tag, paste it. Okay, and this is the brand name, so let me give brand name as student management system. Alright, and let's add a navigation to navigate to the students page. For that, let's use Thymlib attribute here, th:/href, and add students. All right, so here at represents a reference to context path of your application. In our case, this is a project name and followed by slash and then students, and here we are going to use student management, something like that. And let's remove these two links. Okay, and let's copy this nav tag and go to create student.html page, and just below body paste it here and save it. And let's go back to the browser and just refresh, and let's see how it looks like. Yeah, it looks good, right? And go to create new student page, and look at here. Here we need to add some breakpoints, so let's go back to our application, and inside create student.html, just below nav tag, we're going to add some breakpoint here, some break tags, save it, and let's go back to the browser and just refresh, and here we go. It looks good now. So once you click on student management here link, it will navigate to the list students page. We have successfully added header. Let's implement update student feature step by step. So first, what we're going to do is we're going to add here one update button inside actions column. Once we click on update button, it should navigate to update student page, and over there we populate this data, and then user can able to update this update this student. It's pretty simple. So let's first add a update button inside actions column. So let's head over to STS ID and let's start coding. So go to students.html page and go to table. Within a table we have table header, and we have added actions columns over there, and inside table body we are going to add a button. So td, just type here td, and here we're going to provide anchor tag th:/href. So this is the Thymlib attribute to provide a link, and the syntax for adding the link at within a curly braces /students/edit and then student ID. And look at here, this ID we need to get from student model, right? So student model has ID, so we need to get ID from student object. For that, here is a syntax. id equals to dollar and then curly braces and then student dot id. So this is the standard, standard syntax to get the id. Just remember this one. And let's go and let's add a bootstrap css class, that is button and then button primary. Okay, so save the file and let's head over to the browser and refresh, and let me add a button name here, that is update, and save the file, and let's go back to the browser again and refresh, and there we go, we have successfully added update button. Now once we click on update button, we should open update page, right? Update student page. For that we're going to add handler method to handle this request. So let's head over to student controller class, and here we're going to add a handler method to handle update request. So let's write a method here, public string, and then the method name is edit student form. Okay, and here we're going to use add get mapping annotation, and here we need to provide the URL. So let's go back to students.html file, and this is the URL we have provided, right? Just copy this URL and let's go back to again student controller and just paste it here. And after that we're gonna use add path variable annotation to get the ID. Okay, we need to bind this ID to some Java variable, right? In order to do that, we're gonna use add path variable annotation here, and this is a long type, and this is ID, and again second parameter is model. We need to return we need to return some data to the view, right? For that we're gonna use a model here. Perfect. Okay, now we need to get a student by ID from the database. For that we have to add a method to the student service. So let's head over to student service interface first, and in a student service we're going to add a method called update student update student, and then just pass the argument as student. And apart from that we're going to also need to create one more method which will get a student by ID, get student by ID, and then just pass the ID as a method argument. And then once we add these two methods to student service, let's go back to student service IMPL class and implement these two methods. Okay, and let's first implement get student by ID. So it's pretty simple. We just need to call student repository. It has find by ID method, and just pass the ID here. And look at here, find by ID method returns optional, so we need to call its get method here. Okay, so this completes get student by ID implementation. And next let's update the student, and in order to do that we're going to call student repository object, and it has a save method, and just pass student object to it. Alright, we have successfully implemented get student by ID and update student method in service layer. Now let's head over to student controller. Okay, and just add a data to the model dot add attribute, and this is the student. Now we need to get a student from the database by ID, right? So for that let's call student service and then call get student by ID and pass the ID here. That's it. And here we need to return the view, right? That is edit underscore student. We haven't created edit underscore student view yet, that we are going to create right away. Okay, let's copy this edit underscore student string and let's go to the templates folder. Right click on templates folder, new, and then choose HTML here, HTML file, and just give HTML file name as edit_student.html. hit enter, and this edit_student.html page, it should look similar to create_student page. So what I'm going to do is I'm going to just copy all the content from create_student.html file, and I will paste in edit_student.html file, and let me quickly do some changes. So everything remains same, just here update student, and then here we need to provide the action link here. So action link is student slash and then ID. So look at here how we get the ID. So we have added a student object to the model in student controller light here, so we can get ID from student object itself. Alright, so in order to get ID, what we're gonna do is we're gonna simply use a dollar, and within a curly braces we can access the object, that is student object, and then ID, and just close the curly braces here. So this is the syntax to get a ID from the student object. Okay, so there is no change. Alright, the update page almost looks similar to create student page. So we have done only two changes, that is we have changed the string from new student to update student, and then we have changed the action, the form action. That's it. Okay, it looks almost similar to create student page. Now I'm going to create a handler method to handle this request. Okay, let's go to student controller, and here let's write a handler method to handle the update student form request. Okay, just create a method public and then string, and method name is update student, and here we're gonna pass the ID, that is long ID. Okay, and let's annotate this method with add post mapping annotation. Okay, and just provide the URL, that is slash students slash and then ID. Okay, and this is the URI template variable, and we need to get this value of this ID, and in order to do that we're going to use add path variable annotation here. Okay, so after that here we're gonna we want to store the student form data into some Java object, right? In order to do that we're going to use add model attribute annotation here, and we just pass the object name, that is student, and we need to bind this data to the student object here. Okay, and after that we need a model. Okay, perfect. Now once we get a student here, what we're gonna do is we're gonna update this student. We're gonna first okay, now what we'll do, we'll get a student from the database, and we'll update that student with this student object, and then we'll save into database. So first get student from database by ID. Okay, student, and then call it as existing student. Okay, and we're gonna use student service here, and it has get student by ID method, and pass the ID here. So once we get the existing student from the database, then we're gonna simply update its first name, and similarly let's update its last name. Existing student dot set last name, and here student dot get last name, and existing student dot set email, and student dot get email. Okay, after that we need to save updated student object. Okay, in order to do that, we're gonna again call student service, and it has update student method, and just pass the existing student object to it. And once we update the student, then we need to redirect to students page, right? Perfect. All right, so let me check if there is anything missing. Here we need to also add id to the existing student dot set id, and just pass the id here. Yeah, that's it. So save all the files and make sure that your Spring Boot application is up and running. Let's head over to the browser and refresh, and now we are going to test the update student functionality. So let's first update the student called Ramesh here, and click on update, and there we go. So update student page successfully opened up, and now the data is also populated. So let's go and let's update the student first name from Ramesh to Ramesh to John, and last name to Sina, and student email ID something like sina@gmail.com, and there we go. So first student is successfully updated. Now let's see one more student. So we are going to update second student, that is Sanjay. So let's say from first name to let's change the first name from Sanjay to Sam. Okay, and let's change the email and hit submit, and there we go. All right, we have successfully implemented update student feature. So far we have implemented list students feature, add students feature, and then update students feature. Okay, now what we're going to do is we're going to implement delete student feature. So what we're going to do is we're going to add a delete button over here, and once we click on delete, it should be able to delete the corresponding student. Okay, let's head over to STSID and let's add a delete button in an actions column. Let's open students.html page, and this is the actions column, and go to the table body, and here we're going to add a delete button. So delete button almost looks similar to update button. Let me copy this update button code snippet, and here what we're going to do is we're going to simply remove edit here, and that's it, and change the button name from update to delete. That's it. Now let's go back to the browser. So yeah, let's also change the Bootstrap CSS class from primary to danger, and save the file, and let's go back to the browser and let's refresh, and there we go. A delete button we have added successfully actions column. Okay, now once we click on delete button, we should need to handle this delete request, right? So in order to do that, let's create a handler method to handle delete request. So let's head over to student controller, and here we're going to add handler method to handle delete student request. Okay, create a method here, public, and then string. Return type of the method is string, and here users queue method name is delete student. Okay, and let's annotate this method with add get mapping annotation, and just add the URL, that is students, and then template variable, that is student ID, and we need to get this ID value. For that we're going to use add path variable annotation here, and then type is long. Okay, all right, so we need to delete this student from the database. For that, what we're going to do is we're going to add a method in student service. Okay, go to student service, and here we're going to define the method delete student, okay, by ID, and just pass ID here. Okay, save the file and let's go to student service IMPL class and let's implement this method. And just call student repository and then delete by ID and just pass the ID. Okay, that's it, pretty simple. Now once we implement delete student by ID method in service, then we can call this method from the student controller. So head over to student controller and here we're gonna call student service and its method delete student by ID and pass the ID. And then after that, once we delete the student, then we should return to students page, right? For that, let's redirect to students page. Perfect. Okay, let's save the file and let's see how this delete student functionality works. Okay, once you save all the files, then go to the browser and refresh, and now we are going to delete first student, that is John. So just go ahead and click on delete button here, and there we go, a John student is successfully deleted. Now let's go ahead and let's delete one more student, that is Sam, and there we go. And let's delete this last student, that is San1, and there we go. Alright, it means that we are successfully implemented delete student feature. Okay, great.